Hi everyone, welcome back to another video. So we're just continuing on with our trigonometric fundamental identities. We've done the first fundamental identity, so we're going to move on to another 2 or 3 identities in this video. The basic thing to remember is that first fundamental identity that we learned in the last video, which was cosine squared plus sine squared equals 1. Then what we're going to do is we're going to derive from that some more fundamental identities that we're going to remember and pen down and just get used to. The more you use them, the more you memorize them. So let's get straight into the chapter. We'll carry on reading. So we're on page 259 of the trigonometry chapter, and we're on the 33rd part. So let's start reading. So 2 more identities can be derived directly from the fundamental identity. Dividing both sides of the fundamental identity by cosine squared gives the identity, and then 1 plus tan squared equals secant squared. So like I mentioned, the thing to remember here is the first fundamental identity, which is cosine squared plus sine squared is equal to 1, right? And what we're saying here is that if we divide if we divide the whole thing by cosine squared, then that will give us a new fundamental identity. This is basically the way to look at this is algebra. You know, when we had an equation, 3x plus 1 is equal to, I don't know, 4. Then if you times everything by 2, the equation is still basically the same. It's a new equation, but you could obviously just divide it by 2 to get back to the first equation. So, we're just multiplying every part of this identity by cosine squared. So let's do that now, right? So remember, this is the fundamental identity. So let's take it over here, divide it all by cosine squared. We've got cosine squared plus sine squared is equal to 1. Divide that by cosine squared, divide that by cosine squared, and divide this by cosine squared. All right. Now, tell me, cosine squared divided by cosine squared equals 1, right? Obviously, anything divided by itself is equal to 1. Sine squared divided by cosine squared. You should be kind of getting used to this now. It's tan squared. In case you're not sure why, we'll work that out together. And then 1 divided by cosine squared. So that's the reciprocal of cosine, right? The reciprocal of cosine squared, because 1 over cosine squared, which is equal to what? Secant, right? So remember, the reciprocal of tan is cotangent, the reciprocal of cosine is secant, the reciprocal of sine is cosecant. Yeah? So just bear that in mind. So these two, this should be simple. You should get this. Maybe the tan squared one you don't get, so let's work that one out. We'll work it out over here. So what we're going to do is we're going to prove over here. We're going to prove that sine squared divided by cosine squared is equal to tan squared. Yeah? Okay, so sine is what? Opposite over hypotenuse, right? And so this is sine. And cosine is adjacent over hypotenuse, yeah? So sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So if we divide sine by cosine, what we're basically doing there is we're basically dividing opposite over hypotenuse, all divided by adjacent over hypotenuse, right? And then so you could now cancel out these 2 hypotenuses. Obviously, they're going to cancel out each other, so you're left with opposite over adjacent, right? And if you remember, tan is what? Toa, soka toa. So tan is opposite over adjacent. That's tan. So these 2 are equal. Therefore, sine over cosine is equal to tan. And so we're saying that up here we're saying sine squared divided by cosine squared. We know that sine divided by cosine is tan. So then just the square of it is squared again. So sine squared divided by cosine squared is equal to tan squared. So we've just proved that there. So now if we just complete this equation, we're saying that 1 plus tan squared is equal to secant squared. And now this is your second fundamental trigonometric identity. Cool. So let's write them out a bit. We'll try and keep track of them. So let's do fundamental. And we're going to say number 1 is cosine squared plus sine squared equal to 1. Number 2, we're going to say is 1 plus tan squared is equal to secant squared. Alright, let's carry on through the book. And so he just explains that here, right? So dividing a fundamental identity by sine squared gives a third identity. So now what we're talking about is dividing this first identity, dividing both sides by sine squared. Remember, all we're doing was just manipulating the equation basically. The same as what I mentioned about 3x plus 1 is equal to 4. Then if you times both by 2, you'd get 6x plus 2 is equal to 8. And so you could, divide that by 4 now, all of it. You could times that by 10 if you wanted to. You're just taking the same equation, just manipulating it. So that's what we're doing here. So now let's take this equation, cosine squared plus sine squared is equal to 1. And then let's divide both sides, or divide all of it by sine squared. Let's work that out here. So now we're going to be working out let's work out our third identity. Right, so we take cosine squared plus sine squared is equal to 1. And then we're dividing all of it by sine squared. So you should be starting to get the hang of this now. So obviously sine squared divided by sine squared is just 1, right? And then obviously 1 over sine squared is what? Cosecant. Right, it's just the inverse squared. Yep. And then remember what we did here. Cosine divided by sine. So we said that sine divided by cosine is equal to what? We said it's equal to tan, right? So cosine divided by sine is the inverse, 1 over tan. 1 over tan is just cotangent, right? So then we can just say cotangent squared. I'm hoping I'm not jumping there. I'm gonna try and jump, but if it doesn't sit well with you, just leave a comment below and I'll explain that a bit more. But I'm gonna jump on this occasion. But if you don't get it, just go back and do this part again. Remember, sine squared divided by cosine squared is equal to tan. So if you flip these two here, then you just be flipping this tan is basically tan over 1, right? All things are over 1. So if you then just flip that, then you get 1 over tan. Flip that, flip this side of the equation, and flip this side of the equation, you get cosine squared over sine squared is equal to 1 over tan squared, and then 1 over tan is just the cotangent, right? Cool. So now here you have your third fundamental trigonometric identity. So we could write that out here. 3 cotangent squared plus 1 is equal to cosecant squared. In case you're wondering why are we doing this, it will make a lot more sense in future, especially when you're studying maths by itself. It can be a bit dry and boring, but like for example myself doing electrical engineering, you start to use it in a lot of other modules and you start to go, oh, that's why it makes sense. So yeah, don't worry about it for now. So that's our third fundamental trigonometric identity. And so that's just again explained here. So let's carry on reading from here. Using these three identities and the definitions of the trigonometric ratios, it is possible to demonstrate the validity of other identities. For example, to demonstrate the validity of the identity 1 over, here's a mouthful, 1 over 1 take away cosine plus 1 over 1 plus cosine is equal to 2 cosecant squared. Alright, so let's work our way through that and prove that. So what we'll do is, so what we're saying is they've given us another identity, which is 1 over 1 minus cosine plus 1 over 1 plus cosine is equal to 2 cosecant, so 2 times cosecant squared. And they want us to prove it. So, okay, so we'll start with the left-hand side first. Now, if you're going to add fractions together, you just do like the cross multiplying. So remember, if you was adding 1 over 2 plus 1 over 3, how would you do that? And then kind of get to think about that. Do you know what? Let's do it together. So you should know how to add fractions, but you know, I struggled with this the first time I went through the book. So let's just quickly go over how to add fractions, and you know, feel free to skip ahead 2 minutes if this is easy for you. But let's do 2 over 3 plus 2 over 4, right? If you wanted to add them together, you're basically going to be multiplying, 2 by 4 and 2 by 3 and then 3 by 4. You're multiplying the denominators together, and then you're multiplying across downwards the numerator with the opposite denominator. So you're basically saying that 2 over 3 plus 2 over 4 is equal to 2 times 4 all divided by 3 times 4 plus 2 times 3 divided by 3 times 4. And then that's going to give you 8 divided by 12 plus 6 divided by 12. And now you can add because you've got common denominators, and then that gives you 14 divided by 12. Or you can do 1 and then 2/12, or 1 and 1/6, right? So hopefully this here makes sense, because that's what we're going to do now with this ultra complicated looking equation. You would probably do this in your head. You probably just go, well, common denominator here is 12, and then how many times is that into that? Okay, so 2 times 4 is 8. Okay, you do that probably in your head. So let's do this now. Let's add these two fractions together by cross multiplying, right? So you know what, I'll just detail out a bit more for you what we're going to do. So we're going to do 1 times 1 plus cosine, and then we're going to do 1 times 1 minus cosine, and then we're going to multiply these together as well. Multiply there and multiply there to get the common denominator. All right, so we're going to have 1 plus cosine, right? And then added together with 1 minus cosine, all divided by 1 minus cosine times 1 plus cosine. We don't need to write any multiply, but I'll just put it there anyways. So you see what I've done? I've just multiplied across, right? Obviously 1 times anything is itself, so it's 1 plus cosine here, right, which is here, plus, right, because we're adding them here, plus 1, so from here 1 times 1 minus cosine, so then you get 1 minus cosine, and then all of that divided by the common denominator, which is multiplying these two together, 1 minus cosine plus, or multiplied by 1 plus cosine. And now let's just expand out the brackets, right? So if you had 1 plus cosine, right, added with 1 minus cosine, then obviously the cosines cancel each other out. Cosine minus cosine is 0, and 1 plus 1 is equal to 2. So here you get 2, right, on the top. All right, now on the bottom, you're going to get 1 times 1 is equal to 1. Then you're going to get minus cosine times 1. Right, you're doing that here. Minus cosine times 1 is equal to minus cosine. Right, then you're going to get 1 times cosine, which is going to be equal to cosine, so plus cosine. and then you're going to get minus cosine times cosine, which is going to be minus, because the minus times plus is a minus, minus cosine squared. Right? Then you could arrow it here, arrow it this way, which way we're working, and that equals 2 over, and then 1 minus, so minus cosine plus cosine cancel each other out, so you get 0. You get 1 minus cosine squared. Alright, so we're still dealing with the left side. Now, if you're looking at this and you spotted something, well done. If you haven't, don't worry about it. But in terms of the denominator here, we can use the fundamental trigonometric identity, the first one. Here, let's copy and paste it and put it down there. Alright, so look at that and tell me what you could do. Well, 1 minus cosine squared, if you just took obviously cosine squared from both sides, right, you'd be left with sine squared is equal to 1 minus cosine squared. So we could replace this whole thing here with this. Let's do that. 2 divided by sine squared. So 1 minus cosine, because look, we've put it here, right? Right? We're saying that 1 minus cosine squared is equal to sine squared. So we just replace, because it's equal, they're equal to each other, we just replace that. So 2 over sine squared. Right? Now, 2 over sine squared is basically like saying 2 times 1 over sine squared, right? Which is also the same as saying 2 times cosecant squared. Think about that. 1 over sine squared is obviously actually cosecant, right? Which is the same as 2 cosecant squared. Now, what was he trying to prove? If you remember, we was proving here that 2 cosecant squared is equal to 1 over 1 minus cosine plus 1 over 1 plus cosine is equal to 2 cosecant squared. So as you can see, by jumping through all of these hoops, so we started off here, 1, 2, 3, 4, 5, 6, 7, 8. Took us 8 steps to figure out, obviously I could have shortened it a bit, but it's fine. Figure out that this is equal to this. And there we go. We've proved here, and so here they work it out the same. We've proved here that 1 over 1 minus cosine plus 1 over 1 plus cosine is the same as 2 cosecant squared. So that might be a little bit confusing, and don't worry about it. But we're basically going to do quite a lot of these anyway, so you'll get used to it. So in the next video, what we'll do is we'll try this next one. Tan plus cotangent is equal to secant times cosecant. Cool. Alright, I'll see you guys in the next one. If you enjoyed the video, leave a like, and thanks for watching. Peace.